This video is going to be about solving quadratic equations with the square root method. And this is really a pretty easy thing to do. So here's an example. I've got x squared minus 25 equals 0, and I want to find out what x is. So the first thing I'm going to do is isolate the x squared, which means in this case I'll add 25 to both sides. That's going to give me x squared equals 25. Now, if you stop for a second and see what I've got here, you realize what this equation is saying is there's some number that we're calling x, and when I square that number, I'll get a 25. Now, you know you can multiply 5 times 5 and get a 25, but don't forget you can also multiply two negative numbers and get a positive. So we could have had x equaling 5, or x might have equaled negative 5. Negative 5 squared is also 25. So what I'm going to do is I'm going to write x. I'm going to think of myself as taking the square root of x squared. And then I'm going to have the positive and negative square roots of the right side of the equation of 25. In other words, x could equal the positive square root of 25, or it could equal the negative square root of 25. Now the square root of 25 is 5, so I'm going to have x equals plus or minus 5. And if you plug both plus and minus 5 back into the original, you'll find they balance either way. So 5 squared is 25, minus 25 is 0. Negative 5 squared is 25, minus 25 is 0. Okay? So what you do in the basic method is isolate the variable, the x squared in this case. So you have the x squared on one side, you have your constant number on the other. Then take the square root of the x squared, which will be x, and the positive and negative square roots of the constant. And then find out what that square root is. Okay, here's a few more examples. In this one, I've got x squared minus 8 equals 0. So isolating the x squared by adding 8 to both sides, we get x squared equals 8. So x is going to equal the positive and negative square roots of 8. Now we're not done because we have to simplify this radical. And I know that 8 is 4 times 2, and 4 is a perfect square. So I'll have x equals plus or minus the square root of 4 times 2. And then I'll just pull out the square root of 4. So I'll have x equals plus or minus 2 times the square root of 2. Okay, here's another one. X squared minus 7 equals 11. I want to isolate my variable, so I'll add 7 to both sides. On the left side, I just get x squared. On the right side, I've got 11 plus 7 is 18. So x is going to equal the positive and negative square roots of 18. And now I've just got to simplify the square root of 18. So x equals plus or minus the square root of 18 is 9 times 2. 9 is a perfect square. So I'll take that square root out. I'm going to have x equals plus or minus 3 times the square root of 2. Okay? So reviewing this once again, you're going to isolate the variable on one side of your equation. You probably have to add or subtract something. And we'll get the variable on one side, a constant on the other. And then you're going to take that variable, which was squared, and take its square root as an x, or is it just x or a, whatever it is. And on the right side, you're going to have plus or minus the square root of whatever the constant was. And then just simplify that square root. Okay, so that's all there is to this. There is one place I want to warn you about. So look at one more example. Here I've got x squared plus 16 equals 0. So I guess if I want to isolate the x squared, I'll subtract 16 from both sides. And now I've got x squared equals negative 16. Okay, let's stop and look at this. This is saying that I've got some number, which we're calling x, we're squaring it and ending up with a negative 16. Well, this is impossible, because if I square 4, 4 times 4 is positive 16. If I square negative 4 times negative 4 is also positive 16. So if you see a situation like this where you have a square on one side and a negative number on the other side of the equation, don't go any further. Just write no solution and go on to the next problem. Okay, so that's really all there is to it. I'll see you next time.